Hey everybody, so today we're going to start talking about modular code. And modular code, at least modular code that you write, is the idea that when you write your code, the code is modular. This is a silly way to describe it, but the idea is that the different pieces of the code are separated from each other in such a way that you can tell what each piece does independently of the other. So when we talk about modular code, we're looking for a couple things. One thing that we're looking for is we want to have functions that each perform really a single task that is what you're trying to accomplish in your program. The second thing is that variables and function names are clearly named to describe their purpose as best as you possibly can. The goal of modular code is to make your code easy to read and well organized. And it also makes it so that someone who is not accustomed to your code can take a look at your code and understand without too much work what it is that your code does. So let's take a look at an example to see how we can actually go about writing modular code. So here we have a program that I've written in MakeCode for microbit, and I'll show you quickly what it does. So when we run this, there are a few things happening. First thing is, when I take the temperature detected by the microbit and raise it and lower it, you can see that above a certain threshold, 30 degrees, that middle LED on the microbit flashes on and off. So that's the first thing. The second thing is when I take this and tilt it from side to side, you can see when it's tilted to the left LED is on. When you tilt it to the right LED is on. And when we have it somewhat in the middle, we have the middle LED lit. And the third thing is that when I press the A button, this LED turns on for just a second. So those are three things that this code does, and you can see that I have all the code to do this. What you can see when you analyze this code is that each piece is using a different sensor, a different input on the microbit to manage an output. So this piece right here is using temperature. This chunk of code here is using the built-in accelerometer, and this code down here is using the button. And so one way that we could make this code more modular is to write code for each of those three segments. Code managing the button as an input, code managing the accelerometer as an input, and code managing the temperature. So let's write three functions, three separate functions, to actually deal with those three elements. So I've decided that there are three functions, one for each, one for displaying something about temperature, one for displaying something about acceleration, one for explaining something related to the button. And so what I can now do is I can take the code corresponding to each piece and put that code inside of these functions. So you can see I've just taken the corresponding code and pasted it inside the functions. Now I need to call those three functions inside of the main loop. And so now that I've done this, I should expect that when I run the program, I get the exact same behavior. And sure enough, here's the temperature, here's the acceleration, and balance in the middle, and then here's the behavior pressing the button. So I should have my program do exactly the same thing as it did before, now that I've started modularizing it. And so if someone were to come in, they can see that this is something related to displaying something about the temperature, this is about displaying something about the acceleration, or maybe the tilt of the microbit, and this is displaying something related to the button. Within each of these functions, I can further simplify and modularize the code. Remember, I want each code to kind of do one thing at a time, and to make it very clear what it is that a piece of code is doing. So this right here is measuring the input of a temperature. And if the input of a temperature is greater than 30, I do one thing. I can show the middle dot. Otherwise, I could hide the middle dot. Let's take a quick look at what happens if I don't do that. So if I hit the play button, right now we can see that middle button, that middle LED is not shown. If I raise it above 30, it turns on. But if I lower it, it never turns off because I never actually tell it to turn off. So another thing that I could do that might make it a little bit easier to understand for this code is I could write a function that plots the middle LED or unplots the middle LED. And I could use this as a way to further explain what is actually happening here. Okay, so I've written two more functions plotting that middle LED, and I now need to call them. So again, when I call this, when I run my code, I should get the exact same behavior as before, and I do. Okay, now this was one way to modularize the code. You could argue that this wasn't that needed. This wasn't. It doesn't make it that much easier to understand doing this. But I want to just show that you have the flexibility to do this. We could indicate this as a way that we are giving feedback about the temperature. And so it's possible that the process of showing that feedback could be more complicated. And if that was the case, we could do something more complicated. But for our purposes, we don't really need to do that. Let's take a look at another way that we can further modularize this code. We have an if statement checking for 3 different situations. And in each of those situations, it plots or unplots the LEDs above the top row of the display. Okay. Now, if, else, one thing that we can do instead of this complex situation right here, this is kind of a long expression, and so it would be nice if we could come up with a function that describes what it is we're looking for. So I'm going to create a function this time that returns a true statement based on this right here, and I'm going to call this. We can see that this right-hand LED is turned on when it's tilted right, and so I'm going to write a function called tilted right that returns whether or not this is true. So let's do that. Now I'm going to show you 2 ways that we can actually structure this. I could do this. If it's greater than 10, we could say return true, and then we could do else, because if it's not tilted right, we can return false. So this is clearly showing what it is we're looking for in this function. If it's tilted right, we can check if it's tilted right based on this statement, and if that's true, this function should return true. Otherwise, it should return false because it's not tilted to the right. Now, a more efficient way to do this would actually be to just return this value right here. So instead of doing all of that, one thing I could do is just return this statement. So return input.acceleration dimension.x greater than 10. Because if the acceleration is greater than 10, the statement will be true, and otherwise it'll be false. But for the purpose of trying to show you what I mean by having modularized code that is easy to read, I can just do this. So now I have this function tilted right, and I can include this in my if statement. So if tilted right, and I can just call this, then it's going to do this. I can do a similar function for tilted left. Okay, and so you can start to see if tilted right, do this, else if tilted left, do this, and otherwise, if it's neither of those 2 things, then I can plot those. Okay, so we've done displaying temperature, we've done displaying acceleration. let's see if we can modularize display button a little bit. I've already shown you a way that we could take this and maybe separate that into a different function. But let's do this for this sequence right here, because this is a few things happening. It turns on 4.4, it waits a second, and then it unplots that same one. So we'll make a separate function. But this time what I'm going to do is I'm going to include a parameter so that I could actually make it easy to change the coordinate of that button. So I'm going to take all of this, I'm going to create a function, and I'm going to call this function give button feedback, and I'm going to do X and Y. And so the reason I want to do that is I want to give this the possibility of easily changing where that feedback appears. So I'm going to make this X and Y. I'm going to make, this X and Y. And let's also say I want to include one other quantity that I might want to change, and let's just call it delay, and let's say that's a number 2. And so I can make it plot XY. I could pause by delay whatever number I put in there, and then unplot that same XY. Okay, so this separate function is giving me a lot more flexibility. And let's go back to my if input button is pressed, and let's now use this function that I just defined, give button feedback. And I could do for 4 and 1,000 and run the code and see what it does. We can see right now it's doing the exact same thing as what it did before, but now let's say I don't want it to be there. Let's say I want it instead to be I don't know, maybe the top, maybe closer to the top, and let's say I only want it to blink once for half a second instead. So now we run it, I hit the button, and it's a little bit zippier, it happens a little bit faster. And so because I've written this modular function here, I have a little bit more flexibility, and I can more easily change things in my code in one place. So all of this together is supposed to give you an example of what I mean by modular code, how you can clean up your code, make it a little bit easier to read, and also use functions, a few different forms of functions to make to get this objective of making your code more readable and a little bit more organized. So now it's your turn.